This modern tyre is made of 10 to 15 different components, which include natural and synthetic rubber, chemical additives, and carbon black, a pigment. Giant blenders mix these ingredients under heat and tremendous pressure. There are various formulations for different parts of the tyre. In each case, the result is a gummy rubber dough, which machinery then rolls into sheets to await further kneading and processing. Polyester fabric is unrolled onto a machine called a calender. The calender is equipped with rollers that apply warm rubber to both sides of the fabric. This produces a rubberized fabric that will be used to reinforce the tyre. The fabric ply is needed because rubber alone isn't sturdy enough to make a tyre. Lots of cotton thread now spins from these bobbins. Machinery pulls the cord onto the warm rubberized fabric. They land on an angle and stick. This creates channels that provide pathways for venting air during the actual tyre building. Making rubber for the tread requires 3 different rubber formulations. Extruders shape the 3 streams of rubber, and then they enter a die that forms them into one. Paint rollers apply different coloured stripes. It's a coding system for identification of the ingredients during processing. To avoid tension, the system creates slackness in the feed. A blade slices the tread rubber to length. Next, many steel cables uncoil at once to make the bead, the part of the tyre that gives it the strength it needs to stay on the wheel rim. Machinery arranges the cables in the desired configuration and encases them in rubber. More equipment rolls the bead material into hoops, sized to fit the wheel rim. Now the tyre is ready to be built, using a special rotating drum. The 2 bead hoops are arranged on it. Next up is an airtight piece of rubber that will act as an inner tube, followed by the corded ply. Inflated bladders roll the rubber around the bead on both sides and then retract. A server applies sidewalls to the beads. Rollers then fold the sidewalls over the beads. This completes the inner part or skeleton of the tyre. The outer layers are assembled separately, beginning with strips of rubber embedded with steel cord. The system wraps this rubber around a second building drum. Next up are narrow strips of rubber ply. The computerized system winds them with just the right amount of tension for a graduated effect. They're now ready for the last layer, the tread rubber. Machinery applies it to the ply. Now it's time for the 2 parts to become one. A transfer ring collects the assembly and transfers it to the inner part. Compressed air inflates the tyre to shape it, and all the layers stick together. The machine rolls the edge of the tread rubber over the sidewalls. They now have what's known in the industry as a green tyre, an uncured tyre without tread pattern. Next, it's into a mould to bake and shape the tyre. The 2 parts of the mould come together like a waffle maker. Inside, bladders expand to shape the tyre and transfer the tread pattern to it. This cross-section of a tyre demonstrates how all the layers have been fused together. The time in the hot pressurized mould has caused the rubber to vulcanize.